All right, this is homework help for either 9 or 10. So I'm just going to do one of them. So just do the same one I do. So I'm going to do number 9. So you're finding the coordinates of the centroid, not the orthocenter, centroid, given those vertices. So remember, in the lesson we did example 3, what you have to do is find the coordinates of the midpoint of the opposite side. So you get to pick a vertex. Find the coordinates of the midpoint of the opposite side, and then use that fractional distance formula to find 2/3 along the median. So I'm going to just sketch a picture, and it does not have to be accurate. So I'm totally ignoring all of those coordinates because it does not matter. This is just helping me make sense of the problem. So pick one of the vertices. I'm going to go ahead and pick y. So I'm picking y. So I need the midpoint of the opposite side. So I need the midpoint of xz. So find, if I'm going to choose vertex y, the median from vertex y, we need the midpoint of xz. So remember, midpoint is the average of the x's, average of the y's. So just take here and here, average the x's, average the y's. Average means to add and divide by the number of numbers. So there's only 2 numbers, so you're just going to add them together and divide by 2. So we are going to take the first x, which is -3, plus the second x, which is 5, and divide that by 2. That'll be the x coordinate of our midpoint. And then do the same thing for the y's. So then we're going to do comma, then 15, because that's the first y coordinate, plus 10, our second y coordinate divided by 2. That'll give us the average of those coordinates. Okay, so just do that. So -3 plus 5 is 2. 2 divided by 2 is 1. Hey, that's nice. And then we have 15 plus 10 is 25. Divided by 2. That's not so nice, but that's okay. We can deal with it. 12.5. So that's the coordinates of the midpoint. So that would be right here, the coordinates of the midpoint, and I'll just call that M. So that's the midpoint, and then this is the vertex. So we're looking at the median here, so we need to find out 2/3 of this. So you're not going to find distance. You're not going to do distance formula. You're not going to actually find the length of the median. You're not actually finding the length and then doing 2/3 the length. No, 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 no. I want to know where it's placed, not just how long it is, but where it's placed along that line. So that's why we're going to use that fractional distance formula to figure out what's that point right there. That looks about 2/3. So the fractional distance formula, remember, is you're just going to, I'll write it down for both of them at once. So for I'm just going to do separate. So this will be x and y as a point. For x, it's just take your first x and you're going to add to it the fraction, right, that you want times the just the straight up horizontal distance between your x's. So that'll deal with the x values, and it's the same exact thing for the y's, except you have y's. And then for our a over b, it's going to be 2/3 always when we're doing the centroid. So plug in your pieces. So you've got 1, 5 here and 1, 12.5. Hey, well that's nice. Look, 1 and 1, that's going to be an easy one to deal with. So let's do our x's first. So you're going to start with your x1. And so it is important to know which one is which, right? Which one is our first, which one is our second. So it's always going to be the first is always our vertex because we're starting here and we want to go 2/3 from y to m, from the vertex to the opposite side's midpoint. This is only 1/3 here. We want to go 2/3 from here to here. So if you're doing 2/3 here, I mean, technically you could do m to y and go only 1/3, but let's stick with, the centroid formula. We're talking about 2/3 here. So let's do this here. x1 is y, so I'm just going to do, 1. For y is 1. So this is the number I used that's where I got that from, plus 2/3 of the difference between the x's of these 2 points. So that's just 1 minus 1. Again, hey, look, that's easy because that's 0. So since this is since this is 0 times 2/3 is 0, so the coordinate is just 1, right? The x coordinate is just 1. So for the coordinates of our centroid, the x coordinate is 1. Now we got to find the y coordinate. That's where we'll have to do a little more work. So we're going to do those same steps though. So take our y1 this time, which is 5, so that's this number right here, plus 2/3, because we want to be 2/3 along the way, of our difference between our y's, so here and here, starting with y2 minus y1. So it'd be 12.5 minus 5. Okay, so that'd be 5 plus 2/3 of 12.5 minus 5 is 7.5. Okay, so it looks like it's going to be difficult to multiply, but it's not. Just take this over 1, and that's 2 times 7.5. Well, that's nice. It is 15, so that's 50. Oh, what? Okay, because it's 5 plus, that's 15/3. Well, I know 15/3 is 5, and then 5 plus 5 equals 10. So that's the y coordinate of my centroid. So x, y, the coordinates of my centroid are 1, 10. And that's it. Now you could have done number 10, same way. And then also you could have done it where you find the equation of this line and do the equation of another median and then solve the system intersection like we have to do with orthocenter, but no use. This does just the same thing a lot easier and a lot quicker. All right, thanks for watching.